In this module, we're going to learn how to compute power and sample size in STATA. Now it's very important to compute power and sample size before you run your study, before you conduct your data, before you analyze your data, because the last thing you want to do is go through all this trouble and then at the end realize you don't have enough sample size or you don't have enough power. So we're going to show you how to do this in STATA. So in our example, suppose we aim to implement a new physical activity program among school-age children between 6 and 11 years old at high risk for obesity. And we define children at high risk for obesity as those children who perform less than 2 hours of physical activity per week. So we plan to design the survey to test whether the mean BMI in the high-risk children is equal to the mean BMI among 6 to 11-year-olds in the United States. And from a previous study that was conducted, we know that the BMI among children 6 to 11 years old in the United States was 18.4, and it had a standard deviation of 2.8. So the first thing we want to do is we want to state our null and alternative hypothesis. So our null hypothesis, H naught, that's simply that the mean among the high-risk children is equal to the mean of all children, which is 18.4, and all alternative, we're going to use a two-sided alternative, that it's not equal to 18.4. Okay? So now we have various combinations we want to compute power for. So we're going to compute power first. So the first scenario is we have a sample size of 100, and we want to assume that the BMI for high-risk children is 19.4. We're going to assume it has the same standard deviation, and we're doing a two-sided test. So how do we do this in STATA? So we can do this in STATA through the use of the SAMP-SI command. So type in the following command. So now this is the command we're using, SAMP-SI. So the first number, 18.4, that's going to be our null value, and 19.4 is going to be our alternative for which we want to compute either power or sample size. SD1 is for our standard deviation, and N1 is our sample size, and we want to do a one sample test. By default, STATA will do two samples, so we have to tell it we want one sample. So now hit enter. We can see that the power is 0.9465. So for the case where we have a sample size of 100, our alternative is 19.4. Our power is 0.9465. And so now we can go ahead and in the same manner we can compute power for various other combinations. And so if you run in STATA, if you run the commands with these various parameters, you should double check that you should get these answers. You should get 0.7141 and 0.05. And so the thing to note here with this case, this last case, is that our null and alternative are the same value, 18.4. And by definition, your power will now be equal to your type 1 error. And that doesn't matter what the sample size is. So you could have a sample size of 1,000,000, you could have a sample size of 20. If your null and alternative and your hypothesized alternative are the same, your power is going to be equal to your type 1 error. So now let's say we've computed power, so now we want to compute sample size for various different powers and alternatives. So for example, in our first example, we have a BMI, we want to assume the high-risk children have a BMI of 20.4, and we want to find the sample size for us to have 90% power. So we can do this in STATA. So if you go to STATA, now type in the following command. So once again, we can see the syntax is pretty much similar to where we want to compute power. We have, once again, we have SAMP-SI, we have our null value, we have our hypothesized alternative value here in 20.4, standard deviation is 2.8, but now instead of N1 we put power, where we want 90% power, and once again we have to put one sample, because by default STATA will do two sample. Now hit enter, and we can see that the sample size is 21. So we need 21 people to have 90% power, while the alternative is 20.4. So if you run through STATA and you follow the syntax given, you'll find for various powers and alternatives. So for 80% power and the alternative is 19.4, you're going to need 62 children. And if we keep everything the same except we increase the power, we're going to need to increase the sample size. So all else being equal, if we increase the power, we're going to need to increase the sample size as well. Now suppose we powered our study for the one-sided test that the mean BMI is higher in the high-risk children. So now we want to know what is our null and alternative hypothesis in this situation. So our null is that the mean for the high-risk children, is less than or equal to 18.4. And our alternative is that the mean for high-risk children is greater than 18.4. So now once again we want to compute power for various sample sizes and alternative BMIs for high-risk children. So what we can do is go to STATA. Now type in the following command. So as you can see, the syntax is the same as before, except now we want to add this one-sided option. So what we can do is now hit enter, and we see that for a sample size of 100 with an alternative of 19.4, we have 0.973 power. That's a pretty high power, so that's very good. So next, if you compute these in STATA, you should double check your answers that you get the following answers. And remember, for this case here, we have that our null and alternative are the same, so our power by definition is going to be equal to our type 1 error, which is 0.05. Next, we want to compute sample size for various powers and alternatives, so we can do that in STATA again. So for the first case, we want 90% power, and we want an alternative of 20.4. So how many children do we need to sample to achieve 90% power? So in STATA, type in the following command. Now, as you can see, the syntax is exactly the same, except we're replacing n1 by power here. So hit enter, and it turns out that we need a sample size of 17. We want to have 90% power with an alternative of 20.4 and a standard deviation 2.8 and an alpha of 0.05. So once again, you can go through the other examples in STATA, and you should double check your answers that you get 49 and 68 for the following two. And once again, note we increase the power from going from here to here, and as a result we need to increase our sample size. And because everything else remained the same, and if we increase the power, we know we need to increase the sample size as well. All other things remaining equal. Now suppose we also wanted to investigate whether the BMI among high-risk children differed between boys and girls. So now what would be our null and what would be our alternative hypothesis? So the null hypothesis would simply be that the two means are equal. So the mean for boys and the mean for girls are the same. It's in the high-risk population. And our alternative is a two-sided alternative, and it's simply not equal. So now we want to compute power for various sample sizes and alternative BMIs for boys and girls. So for our first case, we decide to sample 20 boys and 20 girls. And we assume the BMI for boys is 20.4, and we assume the BMI for girls is 18.4. So how much power do we have with that test? So we can do this in STATA, so go to STATA once again, and type in the following command. So the syntax is very similar to the one sample case. So here we have our alternative for one group and an alternative for the other group, and we're going to assume the same standard deviation for both groups, that's SD1 and SD2. And then we're sampling N1. In the first group we're sampling 20, and in the second group we're also sampling 20. So we want 20 boys and 20 girls. Now hit enter, and we see that we have a power of 0.6175. Now you should double check for yourself when we compute the power with a sample size for 20 boys and 20 girls, and a BMI for boys of 19.4 and a BMI of 18.4 for girls, you should confirm that we get a very low power of 0.2041. Next thing we want to do is we want to compute sample size. So say we want 90% power for our study. We assume the BMI for girls is 19.4 and the BMI for boys is 20.4. How many do we have to sample in each group? So now we can do this in STATA. And to do this in STATA, type in the following command. So as you can see, the syntax remains the same, except now we exchange the N1 and the N2 for power in our syntax. So once again, go ahead, hit enter now, and you'll see that we need to sample 165 boys and 165 girls. Now you should rerun the sample size calculations for a power of 0.8, a BMI for girls of 18.4, and a BMI for boys of 22.4. And you should verify that you should have a sample size, you need a sample size of 8 boys and 8 girls to achieve 80% power for that design. Now if you go back to STATA, you can also type in dbsampsi. Now if you type that, it will bring up a dialog box. And as you can see here, you can select a 2 mean, 2 sample, 1 sample, 2 sample proportions, but we didn't get into that. And then it also has options. So once again, you can choose to compute either sample size or power, and then you can also change your alpha level. You can compute the power of the test. You can change the type of test from 2-sided to 1-sided. You can also change the ratio of sample sizes. So say you're doing a 2-sample test, and you want, say, more boys than girls, or vice versa, more girls than boys. Or say that's a restraint of your study, that you can sample twice as many boys as girls. So you can change that ratio here in this box right here. And that ends this tutorial on how to use STATA to compute power and sample size.